So here we're going to do 6.5. This is the slope point form. And the last lesson we did, do you remember what we did? Slope intercept form, right? Where it was y equals mx plus b. Now today, this form, slope point form, it's where you see a point right here. So the x and the y make the point that's on the line. And then the slope, this is the m value right here, it's out in front of this bracket. That's why this is called point slope form. So x1, y1 is what you replace with a point value, so a coordinate. And the m is the slope, the rise over run, the rate of change of your line. So if we look at this here, I want you to notice that we've got y plus 1. And the equation up here says y minus y1. So how can we get that minus to become a plus? What would the y1 value have been? So if we have y minus negative 1, and then we simplified that, what does it end up being? Y plus 1. Okay, so that's where, so the y1 value is negative 1. Okay, now let's have a look at what the x1 value is. So that comes from right here. So if I have x minus 2, where it was x minus x1, what would the value of x1 have to be here? 2. Okay, so x1 is equal to 2. So right there and there. So what is the point that's on the line then? 2 comma negative 1. Okay. Now, what is the slope of my line going to be? So it's this number right here that's out in front of that bracket. Okay, so my slope, or my m value, is negative 1 over 2. So what's my rise and what's my run for this? So, but what does negative 1 mean? Down 1 and 2 to the right. Okay, so what I need to do is I need to plot the point first, okay? Plot the point, 2 comma negative 1. So, and then after that, what I'm going to do is I'm going to count out my slope from that point. Okay, so let's do step number 1. So where is 2, negative 1? Right 2 and down 1. Okay, so that's the point. Now if we label it, we need to label it with a bracket, comma. Okay, so we go bracket 2 comma negative 1. So the x value is 2, the y value is negative 1. Now what am I going to do next? So I'm going to count out my slope, and I go down 1 and right 2. And then I'm going to go down 1 and right 2, and I could keep going, right? Now if I wanted to go in the other direction, I have to do the opposite. So I have to go up 1 and left 2. Okay, now I've got a bunch of points, and then I'm going to take my ruler, I'm going to connect them, I'm going to put arrowheads on the end. Let's label another point on the line somewhere, just anywhere. What is this point going to be? Okay, so I can label that point as negative 4 and 2. Okay, so I've got 2 points labeled on my graph. I have arrowheads. I'm good. Okay, so now let's have a look at number 2. So number 2, it says write an equation in slope point form for this line. So that is y minus y1 m x minus x1. So I need to figure out what a point on the line is and the slope. So what is any point. I can use any of these points that show up nicely. So what is the value for this point here? Negative 2, 2. This one here is 1, 1. And this is 4 and 0. Okay. So I can use any of these points. Okay, now I need to determine what my slope is. So how do I figure out what my slope is? Down 1 and over 3. So my rise and my run, my rise is down 1 and 3 right. So it's negative 1 over 3. Now, I can actually write 3 different equations that represent the exact same line. We only need one of them as an answer, okay? But I'm going to show you all 3 just so that you could see how they look different. So the first one, y minus, and I'm going to use this point right here to do that. So what's my y1 value? That's the y1 value is going to be the 2, and then equals, and then I have my slope, and then my x minus, and then my x1 value, which is negative 2. So if I put a negative 2 right beside here, what happens to this negative? It becomes positive. Okay, so now let's do the same thing but for this point. So this is going to be y minus positive 1 equals negative 1/3, and then x minus positive 1. Okay, and then we're going to do that for this point. So I've got y minus 0 equals negative 1/3, and then x minus 4. So either one of these 3 is an acceptable answer. Okay, this is a nice form because you can see clearly what the point on the graph is and what the slope associated is as well. Part B says, write the equation in part A in slope-intercept form. And what is the y-intercept of this line? Okay, so the y-intercept we can see is right here, okay? Now, it doesn't fall on an exact nice point, so not a good idea to estimate it unless we actually figure it out. So let's take this first one and change that to slope-intercept form. So we've got y minus 2 equals negative 1/3 times x plus 2. So what I'm going to do is I'm going to take this negative 1/3 and I'm going to expand it through here. So that's going to give me y minus 2 equals negative 1/3 x minus, and then what's 2 times negative 1/3? Negative 2 over 3. Okay, so now I have to add 2 on both sides, and that gives me y equals minus 1/3 x minus 2 over 3 plus 2. I now need to combine those 2 together. I need a common denominator, right? So instead of 2, what can I change that? 6 over 3, okay? Multiply the top and bottom by 3. So we've got y equals negative 1/3 x minus, so I've got minus 2 plus 6, so that's actually going to end up being plus 4 over 3. Okay, so what is the y-intercept of this line? The y-intercept is? It's 4 over 3. If I want to list it as a coordinate point, I can say 0 and 4 over 3. Okay? All right. Perfect. Next question. So the next question here talks about temperature in degrees Celsius is a linear function of the temperature in degrees Fahrenheit. So since it says function of Fahrenheit, that means it's like C of F equals, and then I have an equation with F as the variable. Okay? So that's how I can tell which is going to be my X value and which is going to be my Y value. So this Celsius is the range, and Fahrenheit is the domain. Okay? All right, I need to write an equation, write a linear equation to represent this function. So what I have is I have 2 points. I have 2 points, and from those 2 points, I can figure out my slope. Okay, so let's take those 2 points and figure out my slope. Y2 minus Y1 over X2 minus X1. Okay, so what are my 2 points? Well, this is going to be a set of points. So I've got 2, 12, and 100, so that's my Fahrenheit, and that's Celsius. And I've got another point of 32 Fahrenheit and 0 Celsius. So we'll call this X1, and this Y1, and this X2, Y2. So then in my numerator here, I've got 0 minus 100, and in my denominator, I've got 32 minus 212. So this gives me negative 100 over negative 180. Now I could reduce this fraction, so now I've got 10 over 18, and 10 over 18 both have a 2 in there, so I can also, so it's going to be 5 over 9. So this is my slope. Okay? And I can put the equation into point slope form, what we just did, using one of the 2 points that I have here. Now, which point is the easier one to use? I can choose the point with the 0 in it, because then 0 is an easy number to deal with, right? Okay, so let's use y minus, and then what's my y value here? 0. And then equals, I've got 5 over 9, that's my slope, and x minus 32. You know what? I'm going to actually change my y value and my x value so that it's the appropriate letter for this question. So what would I change the x to? That would be an F. And what would be the y value? That would be degrees Celsius, and that's degrees Fahrenheit. Okay, perfect. So now let's clean this equation up so that it has less junk floating around. So I can write C equals 5 over 9F. So let's multiply this through and see what we end up with. And then I've got minus, and if I go 32 times 5 over 9, I get 160 over 9. Okay, so this is going to be my equation. Okay. Now part B says use that equation to determine the temperature in degrees Celsius at which iron melts, which is 2,795 Fahrenheit. So we're going to substitute this into our formula. 5 over 9, and instead of the F here, what am I going to put? 2,795 minus 160 over 9. And I can simply use my calculator to do this, and I end up getting 1,535 degrees Celsius. Okay, so you can write a little statement here that says iron melts at 1535 degrees Celsius. Okay. If a question starts with words and is asking you some information, it's a good idea to answer it with a little statement at the end. Okay, so now number 4 says write an equation for the line that passes through S, which is 2, -3, and part A says parallel to the line y equals 3x plus 5 and perpendicular to the line 3x plus 5. So we have to do 2 separate equations. Now, what can you tell me you remember about lines that are parallel? Parallel lines have the same slope. So what is the slope that we're going to use for this question? Use slope equals 3. And we're also going to use point. What point are we going to use? The question, the one that they gave us right here. Okay? We're going to use that for both part A and B. Now let's write it in point slope form, which is y minus y1 equals m times x minus x1. Now I'm going to replace this, and this. So I'm left with y. And then so what value is going to go in for y1? -3. So since I have a negative here, and then if I put in a -3, what happens here? Y plus 3, okay? And then I've got, what's my slope? I'm going to use 3, and then x minus 2. So to finish off my question, I can just leave it like this, okay? So I can tell that my point is -3 and -3 for the y and +2 for the x. So it's, the point is opposite to the sign that connects it. And now for this question, what do we remember about perpendicular lines? Negative reciprocal. Perpendicular slopes are negative reciprocals. Okay, so if the original had a slope of 3, what is my new line going to have? My new slope is going to be -1/3. So I'm going to do the exact same thing as I did before with the point to -3 and put it into this form. What's going to change? Just the value of the slope. Everything else is going to be the same because I'm using the same point. Oh, here. That should be a 3. Okay? So y plus 3 equals -1/3 times x minus 2. All right. Okay, so there's the homework. And that's it for this one.